All right, here we go. So 5H, last exercise of chapter 5. It's just tying everything together. You've got a sketch, find domain, find range, and then apply it to the current context. So let's have a look at the first example. It says a book club has a membership fee of $60 and each book purchase is $10. So as soon as you get into this book club, you have to pay $60 to be part of the club. And then from there, every book that you purchase from there on will be $10. Okay? So the first question, they want you to construct a cost function. So how much does it cost in terms of the number of books that you're going to purchase? So if I join the membership but I haven't bought a book, how much would I pay? If I join the membership and then I bought a book, how much would I pay? How can I model this equation? Now, the question I just said before, and someone kind of whispered it just now, I said, if you just joined and you didn't buy any books, meaning n equals 0, so 0 books, how much would you be paying in total? You joined this club, 60. What if I bought one book and I had to join this club? Because you have to join a club before you can buy. It's like Costco. You join the membership for Costco, you have to pay a certain amount, which I think is about $60 as well. And then, therefore, whatever you buy from there on, that's on to you. Yeah? What if I bought one book? What's my total cost? Good. $60 is the membership cost. I bought one book, so it's 1 times 10 because I only bought one, so one book and each book costs us $10. So one group of 10. Together that gives me $70. But what you're starting to see is I can model this now. There is a pattern to it. If I bought 99 books, how would you work that out? $60 for membership plus $60 plus 99 of those books times $10 per book, and that's 60 plus 990, which, what is that? Is that 1,050? Yeah, I think so. So $1,050. What if the question was instead, number of books I bought was N? You see how I'm modeling it? So for those who don't know how to construct an equation or modeling, that's the toughest part. This is what I do. This is called concrete thinking. So for those who find abstract tricky, start off with numbers that you know. You got to first understand the situation. So if I said, bought no books, join the club. You knew it was $60. Bought one book, joined the club. Well, then that was $70. Then if you can do it for 99, then you can do it for when it's N. So what would the equation be? C must equal to, how would you construct it if N, number of books is bought? Instead of 6 books being bought, instead of 99 books being bought, what if it was N? What would the equation be? Yes, ma'am. That's it. $60 because that's the membership price, plus for every number of book that you buy, which is N books, each book costs $10. That is how you construct. Okay, so you find that same thing with quadratics. When you get a problem, start doing concrete thinking if you struggle with abstract thinking. This is called abstract thinking. If it helps, model it first. Okay, so that's how I normally teach my students to get there. Now, out of curiosity again, do you guys remember what an integer is? Because it says, note, n must be an integer. What's an integer? Whole number. It can be plus or minus. Okay? In our case, in a logical sense, in the real world, you can't have negative whole number books. You can only have positive whole number books. So it's just saying you can only buy one book. You can't buy half a book. You can't buy a third of a book. Right? So here, the next part is sketch the graph filling out the table. Well, we already filled out a few of them. Bought no books was 60. Bought a book was 70. If you buy 2 books, what's the pattern? 80. Good. 80, 90, 100. This is clearly a linear equation because you can see each one is consistent. It's going up by 10 for the y values and it's going 1 across for the x values. So putting them together, C is the cost in the y-axis, N is the x-axis because that's the number of books. If you put it all together, you should have 60, 70, 80, 90, 100. Now, why do you not, no, don't do this bit. Why do you not do this? So don't do that line that I just drew. Why would that be wrong? See, if I drew that line, because we can see there's a pattern, and I know that most students, if I gave them this test, they would have put it in that line. What's wrong? Why can't I put it in the line? That's true too. There should be a limit to the number of books. There's something more obvious. So you have to understand why we can have lines and then why we can't have lines. Because that's the whole point of doing the sketch. Why can't I put in the lines? I had to actually put the dots. I can't put that line in. What's the problem? Yeah, we literally just said, no, n must be an integer. So if I looked at this graph, put in that line, what you're saying is that it can be n could be infinitely many points in between. That means you can have 0.9, 90% of a book, or you can have 190% of a book, which isn't true. You can only have 0, 1, 2, or 3, or 4. You can't have anything in between. By drawing in the line, you're saying that, yeah, you can pay 75 bucks. There's a time that if you've gone in and I said, well, how many books would you have to buy to get 75 bucks? There's no way you can do that. Because you can only get 70 bucks or 80 bucks. There's no way that you would have paid $75 if you walked into the store, had a $60 membership. So that's why when you're doing this as an application, that's the difference between 5H, just doing the mathematics, is that is your graph. That's your graph that continues on. So that's why I wrote here before, note, n must be an integer. Those are the details that you must pay attention to. Then you have to think about it mathematically, what it represents. Cool? All right. Next one. Example 2. I'm going to pause the video and I want you to create the function for this now. This is very similar to the SAC. So if you've seen the SAC and you had some practice over the holidays with quadratics, see if you can construct the equation. So construct a rectangular, provide the maximum area. Let be, okay, so first one, construct a function that will give you the area of the enclosure. So you want to find the area. Okay, so this is what I want. I already gave you a hint. Work out the perimeter. I'm going to pause the video. Let's have a look. For those who weren't sure, this is how we start. We said that it is a 12-meter length of fencing to create this rectangular shape. So that means that if you add all the lengths together of this rectangular shape, it should add up to 12 meters because we used a 12-meter length of wire and you bent it to make a rectangular shape. So we know that W plus L plus W plus L, which is really 2W plus 2Ls, should give you the perimeter. But we already know what the perimeter is because they told you it's 12 meters in length. So you should have an equation. 12 is equal to 2W plus 2L. Now remember, to find the area of this shape, it's width times length, or length times width. What's the problem? We wanted A in terms of L. So the problem is this W. I need to rearrange to get W in terms of L. Okay, I don't want a W there. That's why you needed the perimeter. So here, you can rearrange it now. Move the 2W across. So minus 2W on both sides. 2L, sorry. You will now have 2L. 12 minus 2L is equal to 2W. And therefore, W, if you divide both sides by 2, W should equal to 6 minus L. Hands up if you got this expression, because that was key. Okay, so it's very typical application for quadratics or generally quadratics. So W will equal to 6 minus L. Okay, so the width will equal to 6 take away L. So that means your area, instead of saying W times L, you can now say 6 take away L, which is W, multiplied to L. If you expand the brackets there, you will get 6L minus L squared, and that is your area in terms of L. That's the formula. So as long as you know what the length is, then you'll be able to figure out the area. And if you know the length, you can figure out the width. Okay, so that's what these two are for. Similar to your stack, after this, they normally ask you to find sketching it, find the domain, etc. So that's what we'll likely do. So let's have a look over to the next page. Here we go. They want you to sketch the graph of the function. Now remember the function was A is equal to 6 minus L times L. That means this is your area axis. This is your length axis. Clearly, there's a couple of restrictions that we can see. Area cannot be negative, so you can only have this top half. Length cannot be negative. You can only have this right half. So when you're sketching it, if you type this on your calculator, you'll likely go all the way across. You need to make sure it sits within the first quadrant. So here we go. Let's type it up. Using your CAS, I taught you to define. Hopefully you can do this quickly now. So menu 1, 1, define. A bracket X. Remember, I'm doing X instead of L because when you do the graphing, it doesn't know how to sketch with an L axis. They only know X axis. So A in terms of X is equal to bracket 6 minus X times X. Okay, so all I'm doing is I'm just replacing the L with the X. Here we go. I've defined it. If I sketch it, control, doc, add on a graph, and I type in A bracket X. Here we go. This is my graph. Now, obviously, it's been cut off, so I'm going to go menu 4. Remember, you can do zoom fit. That's one way to do it. Or, in my case before, I can see it's just a bit above, so I'll just go menu 4, 1, and I'll change the Y values to maybe 20, for example. And there you go. See the graph. Now, if you want it clearer, you can use zoom box. Menu 4, 2, zoom box, and you select the corners. So I select left corner, select right corner, and it's a better graph. Okay? Now remember, you're not sketching the entire graph. Remember, the area cannot be negative and length cannot be negative, so you should only have the top half. So it should look something like this. Question is, where are your x-intercepts? How do you figure it out? Yeah, you do 0. So there's two ways. You go menu, analyze 0, go to the left of it, click once, go to the right of it, click once, and we can see it's 6, 0. Which makes sense, because if you look at the equation and you did it algebraically, when area equals 0, you got 6 take away L times L. Using null factor law, L could equal to 0, or 6 minus L could equal to 0, and you can see that L equals to 6 as well. So you can do it algebraically, you could do it graphically, or on your CAS, you could have done it as well. You could have done menu 3, 1, solve, A of X equals to 0, because that's when Y equals to 0. Solve for X, and you get 0 and 6. This is your CAS work from last term. That was a typical SAC question. Okay? So there we go. We now know it's 0 and 6. What else? Well, what else do we also need? We need a maximum, the turning point. You can complete the square, or you can actually just go to menu, analyze, maximum. So here we go. Left of the maximum, right of the maximum tells me it's 3, 9. So I know now at 3, 9, here's my turning point. Let's go up. Let's come down. Notice I put a circle at the endpoints. Why did I do this? Not equal to 0. Why can't I have it equal to 0? What's the logic? Well, like 0 area. So you can't have a rectangle How can you draw a rectangle with 0 area? Doesn't make sense. Okay, so that's why technically you're meant to put an open circle, but I think your textbooks don't do that. But that's something to be mindful of in an application. And so now to answer the question, so hopefully you're not going to screw up. So most students do this pretty well. So in your SAC last term, you guys did well in sketching, but then answering it, you screwed up here. So let's see if we can do it the right time this time. What's the maximum area? Be careful. What's the maximum area? Christina? 9, not 3. A lot of students think it's 3 because that's the first number you read. No, that represents the length. Remember, that's your x-axis. This is your area. So 9 is the area, so write 9, and don't just write 9. If you know the units, then you should write the units squared. What is it in terms of, does it say meters? Yeah, it does say, so it's meters. So it's 9 squared meters. You can get penalized in year 12 if you don't put the units. Okay, so get into the habit of writing units. The domain, clearly the domain is from 0 to 6. Now, I would say it's not inclusive, but your textbook might say it is. Okay, so I would say the correct answer should be x is an element of 0 to 6. Okay, what's my range? What's the range looking at this graph? 0 to 9, very good. And again, depending on your textbook, they might include the points. So I would say it's 0 to 9, or non-inclusive of 0, but it can equal to 9. Okay, so non-inclusive 0 equals to 9 is what I think the range should be, because you can't have an area that's 0, but you can have an area of 9. Okay, so that's what I would write, but you might get confused with your textbooks. Okay, there you go. Now, some of the questions might ask for your lengths and your the maximum length and the maximum width. Again, the width was 6 minus L. So what would the maximum, at the maximum area, what is the length and width equal to? Because that's a typical SAC question. What's length and width equal to at the maximum area? See on? Max area is 9, right? So what's the length at that point? Yeah, it says there. That's all it's asking. So the questions, when they ask you in an application, they're just saying if the length is 3, just looking at the graph, then that means the width must also be 3. 6 minus 3. Okay, so that's a typical SAC question there. Now, your last example is question 8. I'm going to leave it for you to do, but I want you to check your answers for this one and look at the solutions for it, because there is a little key thing that embeds chapter 5 into it. What is it? Technically, it should have been done in this one as well. What's the problem? When you say width is equal to 6 minus L, that means that the length has a restriction. You see, you said width cannot be 0. Width cannot be negative, right? So that also implies that 6 take away L cannot be negative. Doesn't mean that length can be anything, because length clearly cannot be 7, for example. So if length is 7, 6 minus 7 will give you negative 1. Right? So you'll find that in this one over here, you're going to have to be careful of whatever y equals to. Whatever the restriction is on the x, it does matter on your graph. So you find that your graph may not actually go all the way down. It may actually be restricted and it stops somewhere. The reason why it stops is because there is a restriction between x and y. So have a go with this one first, and then I'll show you the solutions and I'll show you where you should be careful of. But let's see if you can see it without me guiding you. Okay, so this is question 8 of exercise 5H. Have a go if you are ready for applications. If you're not, work on 5G or wherever you're up to. But this week is 5G as your main. Okay, so I'm going to pause the video. And it should be recording. All right. Let's have a look. As you see what's board, if you have done this, if you're not, then you can ignore it. You can watch the video later on. Here we go. So hopefully you've done some sort of expression. Now your expression could be different to mine. All I did was I cut it this way. You could have cut it vertically up. It's up to you, but I decided just to do horizontally. So the area of this one would be x times, now this is y minus x in terms of length, because the length is y minus this x will give you that leftover length there. So this area here is x multiplied to y minus x, which is that's area number 1, times width, length times width, so 8 times y. So that's why the area in terms of x and y, this is what you get. Now, when you do the perimeter, I did a bit of a shortcut. I just said perimeter is the length of this entire thing. Instead of finding each individual side, I know that that's y. So this plus this is also y. So I know this is 2y. So that's a y plus a y. 8 plus x is down this way. So that means this side should also be 8 plus x. So all I did was I doubled the y and doubled 8 plus x to give me the perimeter. Okay, so 2y plus 16 plus 2x. Now, let's say you did do whatever method you got. You guys should get the same answers I got here. The next part is the key part. They said, find a in terms of x. So now I don't want any y's in my area if the perimeter is equal to 64. So in your equation, this equation here, you're saying 2y plus 16 plus 2x must equal to 64. Now, since I don't have much space, I'm just going to move it to the side for a bit so you can see. So 2y plus 16 plus 2x has to equal to 64. Rearrange it. So 2y plus 2x is equal to 48 because I take away 16 on both sides. Divide both sides by 2 and you'll get y plus x is equal to 24. Rearrange it so that I get y in terms of x. So y is equal to 24 minus x. Now this is the first restriction. Here's the restriction. Because when I replace that y equals 24 minus x, if I replace it into the area formula, if I take this and I put it back here, the area will give me this. But the problem is y is one of the lengths of this shape. So remember the shape looks like this. Y is here. One of the things that we know about lengths is lengths cannot be negative. So we know y has to be greater than 0. But if that's true, that means 24 minus x needs to be bigger than 0. If you rearrange that inequality, that tells me that x has to be smaller than 24 for that to be true. Does that make sense? So far I'm saying y cannot be negative, but if that's true, then y is equivalent to 24 minus x. So 24 minus x has to be equal to 0. Add x on both sides. That tells me x needs to be smaller than 24. So the number for x has to be smaller than 24 in order for y to be greater than 0. Okay, so that's one of the restrictions that we can see. But there's another hidden restriction. And this one is why, if you look at the answers in the back, see in your area, this bit here, y minus x. Now think about it, you've got two lengths. You've got a length, you already told me that has to be positive. But if I took a length, take away another length, it wouldn't make sense that y minus x will be a negative number. Because if you take two lengths and minus it, you should have a leftover bit, right? So whatever that leftover bit has to be positive. So here's the second restriction. Y take away x cannot be negative. Now if that is true, so I'm going to go back to this one. So here's your second restriction. Y take away x has to be a positive number because you take two lengths, so the y take away the x has to be a leftover, so it must be a positive number. If that's true, y is equal to 24 minus x, but then you've got a minus x here as well. You're saying 24 minus 2x needs to be greater than 0. You see that? So this is the confusing part. See that? Where I'm replacing. Y is equal to 24 minus x. You said minus x there. Minus x is minus 2x. And if you do this restriction, can you see you end up with x needs to be less than 12. So you got two types of restrictions. X is smaller than 24, but then this one says, well, in order for this to be true, X needs to be even smaller. X has to be smaller than 12. So what does all of that mean? It means that when you're sketching the graph, can you see why I gave you 0 to 12? Is because the graph should stop when X equals to 12. It can't go all the way to 24 that you think it would have, because if it goes to 24, then y minus x will be negative. And you can't have a negative when you do y minus x, and that was a hidden restriction on your domain. Okay, so this is not easy. This one I actually forgot as well. I saw this restriction, but I forgot about that restriction. Okay, so this is where at the year 12 level, when you're doing the exams, they will try to embed these small little details. In an application, you have to be careful. And that's what distinguishes the top students who are able to pick up on those little nuances, that lengths cannot be negative, and that means this expression here is key, that every one of them has to be positive or negative. Okay, so that's the only little bit there. If you fix that, then the domain for this question should have been 0 to 12. Okay, and the rest will be the same. So you then sketch the graph, find the maximum, but you got a restriction of 0 to 12 as your domain, rather than 0 to 24. Okay, so that's it for the question. If you want to look at the solutions, just to pick up on the understanding there, have a look at the solutions that are in OneNote. So that's 5H at its most complicated type of question. What do you need to know for chapter 5 before the quiz next week? Literally the basic stuff. Sketch the graphs, domain, range, functions, types of relations, and then finally inverses, which is what I just recapped today. Okay, the 5H is a repetition of what you did last term. We're just adding on a couple of more restrictions. Okay, so I'll stop the video there.